to make, and that is when you have one component solution in principal components analysis, there is no rotation. So rotation only comes into play when there are two or more components or variables. So with one variable, there is no rotation, and that's why we only have this output. And the reason why we got this output is, if you recall, when we did our factor analysis in SPSS under rotation, we asked for varimax. So basically, SPSS is telling us that we can't do varimax rotation because there's only one component na gina-ask or one variable. And rotation doesn't come into play in that case. So as one measure of effectiveness of our solution, we noted the total variance explained by our one component. I had said that 63% siya, di ba? Kung i-round up. So pretty good na siya. So that's one way to look at it. That's all the overall variance that the component accounts for, or our variable. So now here in our component matrix, this tells us some information about how each individual items do in terms of getting that component. So what we have here is, notice we have our five items, SWLS1 through 5, and then we have this column for components. And we have this different value here, and in one component solution, this is pretty nice as this works out very cleanly. And what I mean is that these are called component loading. So people might call them factor loading or depende. They tell you how strong the relationship is between the item and the component in our solution. And if you look at this here, the values here, they are interpreted in a principal component analysis with a one component solution. So these are literally just the Pearson correlation of item with the component, or as we think of the factor, so SWLS1 correlates or loads, people will say 2.747 on the component here as well. And SWLS2 is up, loads or correlates, in this case zero point 0.8 on the component, and so on. And if you look here, our highest loading item is SWLS3, which loads correlates is, if we round here, it's around 0.89 on the component, which is very high. So whatever SWLS3 is measuring, and as a reminder, that question said, I am satisfied with my life ang choice na kagina. So this loads or correlates the highest on the component or any of the items. Now that being said, it should be noted here that all of these items correlate or load very highly on the component or variable natin kagina. It's just that SWLS3 loads the highest, but as SWLS2 and 4 load very high as well, so does SWLS5 and 1, and for that matter as well. So SWLS5 here has the lowest loading, but 0.71 kung round off is still quite good in practice. And in fact, there are some rules that people use here in terms of trying to interpret whether or not an item loads is a meaningful way on a component. And is this case, like I said, all of these do. But people will use, I've seen variety of rules sa on readings varying from here. So it's a zero point 0.3 or higher all the way to zero point 0.5 or higher as being important or noteworthy. So in other words, if SWLS1, let's say here is 0.24 for example, then using the rule of zero point 0.3, I would say this item does not load meaningfully on the component. If it was zero point 0.5, but it's not, so it's a 0.75 here can round off, so it loads quite high on the component, and all these do. But here are variety of rules because may zero point 0.3, zero point 0.4, zero point 0.5, and sometimes people calculate what significance should be an alpha of zero point 0.5 for these loadings and interpret them that way, so on. But here are very high. Okay, this is a very clean solution here na nakita natin. It's a pretty straightforward solution which I wanted to use here for our first look at principal components analysis, as I think it's best to use a simple solution and then build up here to more complex ones, which is, let's go ahead and take this component matrix and go ahead and move it up here just below commonalities. Okay, so let's go and take a look at that. Okay, let's and that will allow us to look at this side by side, which will be easier later. So let's Okay, let's look at this commonalities table. And the commonalities I talk about that our solution indicated that we accounted for 63% of variance for our one component solution that uh, that was pretty good actually. So we saw our factor loadings, our component loadings, and it is the person correlation between an item and the component, that these are all quite good. So now in one component solution, this is pretty straightforward. The correlations here or component loadings, if we square them, it gives us the commonalities. So if we look at SWLS2, it's point 8 kagina, di ba? So if we square that here, it's point 0.8. So if we square that, these ones, it gives us 0.64, which is the one what you see here in commonalities. And if we square these ones, it will give us the values that you have here upstairs. Okay? So ang idalom nga value gin square lang tapos naghimo nga ibabaw nga value, which is the component matrix. And if you recall from regression, actually, if you're familiar with regression, di ba tapos ito? So, R squared is, in simple regression, it's literally just the correlation squared. And the correlation squared or R squared indicates the amount of variance that was accounted for. Well, for the same thing here as well in factor analysis. So, for SWLS2, we have point 0.8 that squared is 0.64, and that indicates the amount of variance that our one component accounted for in SWLS2. So in other words, 64% of the variance in SWLS2 is accounted for or explained by the component that we retained. Okay, 78% of the variance approximately is accounted for in SWLS3. You can see it here upstairs. Okay, and 65 the variance is counted in S4 or and 50% or half of the variance is accounted for by that component that we have in SWL S5. So these are all very good in practice, guys, and point 0.7 for 78% is really actually very high. And SWLS3 once again is I'm satisfied with my life. So that question, so this is a measure of the amount of variance accounted for once again and the individual items by the component. And in one component solution, it's just literally the component loading squared. In solution with two or more component, okay, it gets a little complicated. Okay, you can just square the component loading to get that. But in one component solution, it's a direct translation, so that's very nice. Now, one thing, when we're naming a factor or component, we have to go ahead and name those components because they don't come out with a name. All we know is that we have one component. So our job is to name that one. And what we would do is we would look at each of these items, look at the actual text in those items, and what is it that they're measuring, and and then see which item loads high on this component, and the item that loads high muna siya ang mahatag sa aton sang good indication as to what the component is measuring. So we would literally have to read all those items here and see what they're measuring. So that's those items are in common, and that's what we would name this component. Now in this case, all the items have load very high on the component, so they're all contributing. But we just look at the highest one for the moment, which is 0.89. So 0.89 to siya. Sorry, good, sorry, good. So in SWLS3, once again, SWLS3 is I'm satisfied with my life. So we could say that this is life satisfaction. That's exactly what this is. So it's the satisfaction with life scale actually. And the other items too, they're all measure life satisfaction in one way or another. So just as a couple here, number one, once again, in most ways in my life is close to my ideal. Number two is the conditions of my life are excellent and so on. So all these items are really getting at life satisfaction. But if one of these items are very low, for example, SWLS5 here, the lowest one that we have. Uh, okay. Mhm. Okay. So typically we close in factor analysis. Okay. So, in case here sa aton SWS5, hindi naton siya daron sa pag-name ka aton nga item kay siya ang pinaka-lowest contributing in naming the component. So, typically, we close in factor analysis after getting all our values, determining how many components to extract or retain, and we look at our loadings and then we want to name our components. So, that's it for now. This concludes my report. So just a quick recap, our factor analysis here in SPSS explained to us that this is actually a method of data reduction by deriving one variable that best describes the correlation between all the other variables. So this is actually best used when we have a lot of variables kag kinanglan naton mangita sang isa lang ka variable nga makorrelate ka tanan-tanan or naga-correlate sa tanan-tanan. So base di sa aton nga component nga contributions, pangitaon nato ng mga highest contributor and those contributors will be the derived names. Dira ka ta ma-derive ka name ka aton nga component. So that's it everyone. Thank you so much for listening and for your time, and this is our report, my report, and together with Ma'am Teen Manalo, which is very very gracious and kind gid for helping me with this one. And that is our factor analysis. Thank you very much and have a great day.